Hey there, this is Kamal, and in this video, we're going to see how to recognize faces using OpenCV. So, let's get this started. So this video is actually part of the face recognition series that I'm doing on Python, and this video is actually the third video in that series. So we already had two videos where in the first video, we saw how to identify faces using OpenCV, and in the second video, we've seen how to generate a dataset by capturing the images from a live video. And in this video, we're going to use those two concepts and implement them and try to create a recognition software which is pretty accurate and recognizes our face. So if you haven't seen those two videos, I'll link the playlist in the description down below. You can go there and see those two videos first. Then after you're done with that, then you can carry on from here. So this is the project structure that we had in the previous video. So we had the generate_dataset.py, which is the file or the script that is going to run and generate the dataset. So what I've done is that I have a dataset folder. In that I have two folders named as Chris and Robert. So I already have a dataset created here. So I have 5 images for each of these. But the thing is that all of these images are cropped so that only the face is visible and nothing else. So what we're going to do is that we will just modify the previous script that we had, that is the generate dataset, and make it so that the files that we're trying to save are actually cropped before saving. So what I'm going to do is that inside the for loop where we actually generated the coordinates, I'm going to create another array and place all these 4 values, that is x, y, w, and h, into that array or list. So now that we have the coordinates, what I'm going to do next is that before actually saving the image, we're going to generate a cropped version of the original image. So what I'm going to do is that So this is the logic that is actually used to generate the cropped version of the original image. So we're using the original image, and since the original image has values, that is the x and y coordinates, what we're going to do is that we're going to pass in 2 values. The first one is the y coordinate, which is given as y plus h, and the second one is the x coordinate, which is given as x plus h. But the thing is that this x and y values are actually present inside the coordinates array, and this y actually represent the second value, and h represents the 4th value. So instead of writing it as y colon of y plus h, what I'm going to do is that I'm going to take the coordinates array and access the second element, that is 1. As 1 represents the second element, since you already know that a list starts from 0. So 0 is represented by x and y is represented by 1. So I'm going to use 1. Then colon. Once again, I'm going to take the y value and add that to coordinates of third, which implies the value of h. Similarly, I'm going to do the same thing for x implies x plus h. So now that we have generated the ROI image, where ROI represents the region of interest, and in this particular image, the region of interest is the face. So I'm just going to pass that image instead of the original image. So that is ROI_img. So now if you save this and try to execute this script, what happens is that instead of saving the original image, we're going to save the cropped version of the original image inside our dataset folder. And once you've generated that dataset, the next thing that you have to do is that you have to take this dataset and train a particular model which we're going to use to recognize the face. So what I'm going to do is that I'm going to create another file called as train_model. So the first thing that we have to do is that we have to import the modules. So along with these 3 modules, we're going to need another library called as pillow. So that is not present by default in Python, so you have to install that. So what I'm going to do is that I'm going to open my terminal and I'm going to type in pip install pillow. So right now I'm on my Ubuntu system, that's why I'm using pip 3. But if you're using on a Windows system, you can use directly pip install pillow. And once it has been installed, then what you can do is that you have to import it. So the way that you actually import it is that from PIL, which stands for pillow, and that is actually the wrapper class which contains the module that we're going to use. So inside pillow, we're going to need a particular module called as image. So now that we have imported all the modules, the next thing that we have to do is that we have to train the model. So for now, what we're going to do is that we're going to create 2 lists, and the first one is going to be named as names, and that is going to be an empty list, Along with that, we're going to create another list called as paths, which is going to contain the path to each and every image present inside our dataset folder. Currently, we only have 2 folders inside dataset, and each of those 2 folders contains 5 images respectively. So now we're going to take the names from the dataset folder and add them to the names list. So that is Chris and Robert will be added to names list. So what we're going to do is that we're going to type a for loop. So what's happening here is that we are taking the dataset folder and we are trying to list out all the directories present inside the dataset folder. And currently we have 2 directories called as Chris and Robert. So we're going to take the names of each of these 2 directories and append that to the list that we have called as names. So now we have all the names of all the users. The next thing that we have to do is that we have to get the paths to all of these images. So we are trying to take each and every name present inside the names list and use that particular name to access each and every image present inside that particular dataset folder. So now we have access to all the images present inside this particular folder, and all of them are present inside a variable called as image. So now we're going to use the name present inside the image and append that to the directory that we already have. Then we're going to use the methods present inside the OS called as path join, and for that we're going to pass in 2 parameters. The first one is going to be the root directory name. The second one is going to be the image name. So this image contains the value of 1_1.jpg, and that is being appended to dataset / the name and dot image. So this path_string is going to contain the string, which is something like this. It's going to contain dataset / the username. For now, let's say it's Chris. In that, it's going to take 1_1.jpg. So this path_string currently consists of this string. And whereas this dataset / Chris is being taken from here, and this image contains this value. So now that we have this path, we are going to append that to the paths list. So now if you try to print out that, so let's say I'm going to print it out and I'm going to type in paths and save it. So now if you open your terminal and try to execute it, so I'm going to type in Python 3 and the name of the file, so it's going to be train_model. So you're going to get dataset / Robert / 2_3.jpg. So that's the location of this particular file. So the thing is that since I'm using an Ubuntu based system, I've given it as dataset /, but if you're using a Windows system, you might have to give it as \, and you have to check that. So what you can do is that you can just try it out with / and try to print out the paths, and if there's any change there, you can just change it from / to / here and also here. Okay, but since I'm on Ubuntu system, I don't need to do that. Alright, so now that we have all the paths present inside the paths list, the next thing that we have to do is that we have to get the image from that path and convert that image into a NumPy array. So it's something like this. So we are trying to take the image path from the paths list, and we are using that image path to open that image. So we are using the image that is present from the pill and trying to open that and convert it into black and white. So we are using the convert method present inside the image. So previously in the previous script, we used OpenCV to convert it into grayscale, but now we are using the image method. So since we have the image present inside a variable called as image, we're going to use that and pass it to np, that is NumPy, to convert it into an array, and that value is present inside img np. So now that we have the image data, what we have to do is that we have to append it to a list which contains all the data of each and every face. So we're going to create a list and call it as faces, and that's going to be an empty list. Similarly, we're going to have another list which is called as IDs, which is going to contain the NumPy value of all the IDs. And this ID is actually what is being represented here. So this 1 represents the ID of Chris, and this 2 represents the ID of Robert. So the first thing is that we have to add the faces to that particular list. So I'm going to type in faces dot append, and for this I'm going to pass in the image. Along with this, what we have to do is that we have to get the ID and also convert it into a NumPy array. So it's something like this. So I'm using the image path and I'm trying to split it using the slash. So if you try to print out the value of ID for this, and let's open the terminal and try to execute it once again. Sorry, it's not UNIT, it's UINT. It's supposed to be int 8. So now let's try it once again. And as you can see here, we have an array generated here, and which contains dataset, Robert, and 2_3. We only need the third value. What I'm going to do is that I'm going to give in the value of 2 here and try to execute it once again. That is going to give all the paths names, that is 2_3, 2_2. So what I'm going to do now is that I want to split it once again, but this time I'm going to use the underscore. Okay, so since we had this that is equivalent to this, what I'm going to do is that I'm going to split it once again, and this time I'm going to pass in underscore. And if you do that, you're going to have 3 values, 2, 3, and JPG. So I'm going to need the 0th value, that is the first value. So if you try to execute it once again, that is going to give each and every ID for all the images. Well, the thing is that this is currently a string, so we have to convert it into an int. So what I'm going to do is that I'm going to typecast this into an int. So this particular line is going to get us the values of this in an int format. So let's close this off. So now that we have the ID, what we're going to do is that we're going to append that to the IDs list. So I'm going to type in IDs.append, and for that I'm going to pass in the ID. So right now we have all the IDs present inside the IDs list in a normal format, but we don't want that. We want it to be in a NumPy array. So what we have to do is that we have to pass in np.array, and for that we're going to pass in the IDs. That is going to convert each and every element present inside the IDs list into a NumPy array, and I'm going to equate that to IDs once again. So I'm just replacing this from a normal list to a NumPy array consisting of all the individual IDs. So now that we have everything ready, that is, we have all the faces and we also have all the corresponding IDs. The next thing that we have to do is that we have to initialize the recognizer or the trainer or the model itself and pass in all of these data. So it's going to be something like this. So we are trying to initialize the LBPH face recognizer present inside cv2.face. So we have it currently linked to this variable. Now we're going to use that object to call a method called as train present inside this library. And for that we're going to pass in 2 values. The first one is going to be the faces. The second one is going to be the IDs. These are 2 lists which are in the format of NumPy arrays. So now that we have all of these and it has been trained, what we have to do is that we have to place that data inside a separate file. So we're going to write this data to a file called as training.yml. This will be generated automatically when you execute the script. So now if you try to save this and go to the terminal once again and try to execute this, it's going to show that module cv2.cv2 has no attribute called as face. So this is happening because the LBPH face recognizer requires another module, and that is OpenCV contrib-python. So the command for installing that is something like this. So it's pip install OpenCV contrib-python. So now if you try to execute it, so now that it has been successfully installed, if you try to execute this file once again, now let's execute this. And as you can see on the left hand side, we have a new file created called as training.yml. So this training.yml consists of all the data which is required for the module to recognize a person's face. So now let's close this off. And since we have done with generating and training the model, the next thing and the last thing that we have to do is that we have to recognize the face. So let's create another script called as recognize. So this script is going to be similar to the first video that we had in this series where we actually identify the face. So I'm just going to quickly copy that from that and paste it here. So this is the code that we had used in that video. So this script is used to identify faces inside a particular image. And I'm not going to use the script that we had written for videos. That is because I don't have a video cam with me right now to show the output. So we're going to test the script onto the images itself. But if you want to do that for the live video, you can just copy and paste that video script and just make the same changes. So now what we have to do is that we have to import the OS module. And since everything has been already initialized, so now we have to initialize the LBPH face recognizer once again. So it's something like this. So this line is exactly the same one that we had in the training_model. Instead of actually trying to write it to a file, what we're doing now is that we are trying to initialize the face recognizer and try to read the data from the training.yml file that we had created. So now that you have initialized it, the next thing that you have to do is that you have to identify and recognize the face. But before doing that, let's first actually get the names of all the users present inside the dataset. So let's go back to training model, and in that we use this line, right, to actually get the names. So let's copy that and paste it inside this, and we don't need the paths. So we're going to use this particular line to actually generate all the names of everyone present inside the dataset folder. So now that we have all the names inside the names list, the next thing that you have to do is that you have to recognize it. So now inside the for loop, where we're actually trying to draw the rectangle, what we want to do next is that after we have drawn the rectangle, we're going to type the name of that particular person above that rectangle frame. So it is something like this. So we're using the predict method present inside the recognizer to actually recognize and get the ID of that particular person. And for that, we're going to pass in the gray image. And that too, not just the gray image, we're going to get the cropped version of that gray image. And we're going to use the X and Y values since we are already inside the faces and we don't need to use the coordinates once again. So we can directly use the X and Y values. So now that we have used this, and this predict method is going to return us two values. The first one is going to be the ID. The second one is going to be the confidence. But we don't need that for now. So let's just give it as underscore. And for the first one, I'm going to give it as ID. So next thing that we have to do is that we have to check whether we are able to get the ID. And if we are able to get the ID, what we have to do is that we have to print the name for that particular person which is present inside the names list. So the logic for that is something like this. So we're going to use a method called as putText present inside CV2, and for that we're going to pass in the image, and also we're going to pass in the name present inside the names list. For that we're going to use the ID and decrement it by 1. That is because the names list is going to start from 0, whereas the ID that we're using is actually starting from 1. So if you want to link it, you have to decrement it by 1. And this is going to represent the X and Y coordinate of where the text has to be placed. Right now you can use this and it's going to work. And as for everything else, you can leave it as it is. So I'm just going to give the description for all of these on the repository FAQ section. You can go there and see what these terms mean, but you can just leave it as it is for default and it's going to work fine. So now that we are able to actually put the text, we have to write another else condition saying that if it is not able to identify that particular person, that is, if the ID is not present, that is, the predict method could not actually identify that person, then we have to write the text as unknown. So for that, we're just going to copy this and paste it here once again. But instead of giving it as names, you're going to give it as unknown. And that is all we have to do to actually recognize the face. So now let's just name this to recognize. And the image that we're going to use for this is present inside the test folder. So it's going to be test / inside the test folder we have a file called as chris.jpg. So I'm going to give that name jpeg, and save this. So now if you try to execute this and give the name, so let's type that, and this time let's not use the train model, but let's recognize the file. Okay, so the error is saying that there's no gray image. That is because it's not gray IMAGE, it's gray IMG. So now let's save that and execute it once again. So right now, as you can see, the image has been opened, and also it's recognizing that this face belongs to Chris and the name is being displayed here. So this is going to work pretty fine for most of the cases, but let's say you want to have more accuracy, the main thing that you have to do is that you have to have a larger data set. So I recommend using around 20 to 30 images per person. But since this is just a test video, I only could get around 5 images, and that is working, but sometimes it might not be able to identify. Like let's say I gave it another image of Chris and it might not be able to identify it. So that is going to happen in a lot of cases. So for that, you have to actually use a bigger data set. It's not like you have to have around thousands of images. 20 to 30 is actually a good number, and that is fine. But the main thing is that this recognizer that we're using, that is LBPH face recognizer, is actually present inside the CV2 library. So CV2 library is actually dependent on the deep learning and the machine learning algorithms. But the thing is that since CV2 has been customized so much and it is lightweight comparatively, the things that it could identify and the accuracy that it has is actually pretty low. So this is not going to identify, and it's not going to do well in lighting conditions which are different from the test images, and also in different face angles and all of that. So all around, I could see that this face recognizer only has an accuracy of around 60 or 50%. But let's say you want to have more accuracy for your projects, you can use some of the algorithms which are not available in CV2. So there's one called as scikit-learn, which uses deep learning to identify the faces. The second one is dlib, which is paired with face recognition library, which is also paired with CV2. So if you want to use that, you can use that as well, since that depends somewhat on CV2, and you can use that. And those things have a higher accuracy compared to this LBPH face recognizer, which comes inbuilt with CV2. So if you want to know more about those libraries and see how to implement it on your own projects, then let me know in the comment section down below, and I'll try to continue the series where we can actually test out all those algorithms and also see which one is best for your own particular project depending on the memory usage of all of these algorithms. So that is how we actually identify and recognize faces using OpenCV. And that's it for this video, guys. If you have liked what you've seen till now, then please hit the like button and don't forget to subscribe as well. Thanks so much for watching, and I hope to see you in the next video.